Have you ever thought how do we measure the temperature of the sun or how to measure the temperature of any celestial body or star? So, answer to this question was given by Wien's by his Wien's law, also called as Wien's displacement law. It gives the relation between the temperature of a black body and the wavelength at which it emits the most of light. It is named after the German physicist Wilhelm Wien, who received the Nobel Prize for Physics in 1911 for discovering the law. Hello everyone, my name is Purva Dhopade and I am a first year computer engineering student. My project topic is Wien's displacement law, and in this video I am going to tell you about Wilhelm Wien and his displacement law. We know that any object emits radiation due to the increase in its temperature, then this radiation is called black body radiation. But at which temperature will a body radiates radiation of which wavelength? It was first explained by Wilhelm Wien with the help of classical mechanics. Let's see what exactly is Wien's displacement law. Let us consider the radiation curve of black body, whose temperature is 4200 Kelvin. This curve is between intensity and wavelength. At this temperature, the radiation of longer wavelength is very low. As we come to the shorter wavelength, then there are more radiation radiates to this wavelength. This wavelength is denoted by lambda m. This is called the peak wavelength or dominating wavelength. Even though the blackbody is emitting radiation of all wavelengths, since lambda m is dominating, therefore at this temperature we see blackbody corresponding color of lambda m, which is red color. Now if the temperature of the blackbody increases to 5400 Kelvin, the dominating wavelength displaces towards the left side, that is towards the shorter wavelength. At this temperature, corresponding color of the dominating wavelength is green. Now, if the temperature is increased further at 7200 Kelvin, the dominating wavelength displaces more towards the shorter wavelength. Due to this, the color of the black body changes to blue. From this, we can say that as the temperature increases, the dominating wavelength displaces towards the shorter wavelength. This is called Wien's displacement law. The blackbody curve has different dominant wavelength at different temperature that are inversely proportional to the temperature. When we remove the proportionality constant, then lambda m is equals to b by t, where b is the proportionality constant, also known as Wien's constant. Its numerical value is 2898 into 10 to the power minus 6. Since the temperature of the sun is 5778 Kelvin and it comes in yellow-green portion of the spectrum, the same Orion constellation has two stars, Betelgeuse, which is a red color star whose temperature is 3300 Kelvin, and Rigel is blue giant star with temperature of 12100 Kelvin. Therefore, it can be said that the temperature of the blue star is higher than the red star. Thank you.